Hello everyone, welcome to another episode of the D4 Data Channel podcast. I'm your host Deepak and with me we have Mr. Ashish Patel. Ashish is a highly experienced data scientist currently working with IBM who is interested in various data science technologies. He's a researcher who has written a book about time series and has published many research papers in this field. It's a pleasure to have you here today Ashish and to talk about implementing AI in production. And thank you for accepting my invitation.
Thank you, Deepak. Thank you for inviting me on your show.
Great,
I hope this journey will become awesome.
great. So I have a couple of questions, and starting with this one. So, what are the primary hurdles you observed while productionalizing AI solutions?
So, as per the survey by Gartner and all the big organization, or the we can say the big auditing companies who are just providing the analytics due to some analysis on the production AI. So, like some product facing the ethical issues, some product facing they have a good solution for AI, but they don't able to productionize. So the sometime is like a lack of production engineering, lack of resources, some context the cost is very high on the deployment side. Some context is the scalability issues. Some context is the infrastructure based issues as well, because infrastructure cost of the cloud computing are very high. So yeah, these kind of the lot of issues companies are facing to deploy any machine learning or AI model. Was what happened prepare the machine learning model is nowadays very easy due to the open source technology. But when in terms to productionizing and let's say you want to convert into the business model, then it will become one of the challenging task for anyone, because when wide amount of audience to come to you, so how you can scale your product so everyone can come at your product page, and if the traffic is increased at your product, say how you can just handle the traffic, say that all the things make the difficult to but still we are able to see that we have a lot of products available in the market who are using AI. Let's say Google search, let's say Google. So all the products on the Google using the machine learning. Facebook is using machine learning. Then Amazon is also using that. But yeah, every product has their own level of scaling, own level of deployment, and own level of challenges. So yeah, so how we can handle it, that is nowadays, as per the industry standard 4.0, cloud computing is one of the most trending technology, and everyone should leverage that, but due to their portability, scalability, at one place where you can just do all the stuff, and it's to make a more scalable system. So that's why cloud computing is in the demand and the most viable technology in the era.
Right, right. So,
So,
so
so we are recommending most of the time AWS, Google, Azure, IBM Cloud, which are the more IBM is provide the hybrid cloud AI technology. So yeah, this is one of the industry leaders who are just providing this kind of the scalability and deployment solution issues at scale.
okay. So, in this regard, like, what are the important things to note while building a production grade AI solution?
So whenever you are building any product, first of all you have to follow the each and every step of machine learning lifecycle. Okay, so once you let's say you have a machine learning life cycle, right? So nowadays what happened, machine learning operations are very popular. So that we called in short MLOps, right? Which is very popular. So why MLOps become popular? The reason behind that is like this is operationalizing the production cycle, right? Because what happened, previously we are using the A/B testing. So let me give you the example of one thing. So what a normal data scientist can do is they are making the project of machine learning. They are just build a API in the Flask, and they are just deploying like a normal web application. They are everyone is doing, right. So that way this process working smoothly. But as I told you, when you want to make one process as a part of any a software system or any the portal system, so in that context, you build one process as a AI. So we can say software as a solution, right? or you can say the one module which is become the integral part of any software system. Okay, so for that context, we always prefer to Dockerize your application. So you can use a containerize, you can containerize your application. So you can, and over the containerization, you can use the Kubernetes. And or instead of Kubernetes, let's say you want to make more secure, you can use OpenShift as well. OpenShift is a similar technology like Kubernetes, but it's a secure version by Redux. So in that context, you can use this kind of the technology and you can leverage the advantage of from the security perspective to for end-to-end production level solutions. So if you use a Kubernetes kind of solutions or Docker kind of solution, you don't need to worry about on the production side. Even you can scale your processes, but yeah, when it comes to the hardware so we always recommend to go for the cloud hardware like EC2 instance is there, Azure instances is there, and even you can use a Google Cloud as well, right? For it. So this cloud has click to go facility where you can choose your need based on your product, and you can just within a fractions of second you can just set up the infrastructure. Right. So nowadays, we have a Terraform kind of technology where we can just, with the help of Terraform or cloud formation template, we can set up our own infrastructure on any instances, which with the help of that. Like, so this is not a one-hand process. We need a data scientist, we need a data analyst, we need a data engineers, we need a we need a DevOps engineers. So we need a security engineers, right? So whole process will not handle by the one person. There is a people team, okay, different domain people team who can just help you out to set up whole the environment. So this is a myth like one person can drive whole the data science processes. That is totally wrong. In the context of when you have to just deal with the different problem in the data science, yeah, on that context, data scientist is only the responsible. But when it comes to let's say fetching the data engineers will come into the picture. When it comes to the data governance, that data officer is there, right? Data architect is there. Then above that, let's say you have to set up something, or so you need a cloud security engineers who are providing the access of all the things. Then also similarly, the security part is also equally important because whatever application you are hosting, obviously if your application has a flaw, anyone can hack, anyone can misuse that. So security is a similar concern for the same. So that's why we have to go with all the compliance. So from the security concern to the deployment scalability to the infrastructure usability and everything. So these way I think we have to go.
Right, right. So, what are the common mistakes actually these the engineers make during this model development and deployment phase?
So model development and deployment is people are always trying to search which model is best for which problem. So there is a one word which is very famous, no free hunts. Data scientists are always doing the mistake is like let's say linear regression is there. I can train and if I get the 99% accuracy, it is good. Right. So this is a common myth. 99% accuracy doesn't mean your model is performing good. So first of all, I will tell you in linear regression, we are not measuring the accuracy. Whenever you have a regression problem, we have to measure the R2 score, which is a very famous. And if you don't know the R2 score, or if you find R2 score is very good and in some context, you always have to be a villain. Right? Villain always doubt on the hero skills. That's why hero grow. Right? So this way we have to always doubt on the machine learning model. So you will get a more and more clarity. So let's say your R2 score is not performing good. So on that context, you can apply other matrices to check the performance of the model is like adjusted R2 score. Then RMFC you have. So you have to know each and every step. So like why we are using the R2 score, why we have to use a loss function. Always start the question with why. So that make you more visible to understand that. like how your data is performing, how your model is performing, and you will get to know that like, okay, now this is fulfill the criteria. Then and then you have to go with this model. So for your same practices, we have to do with all the models. And if you want to compare the performance in the context that we have to use MLOps tools. So I must recommend that every data scientist have to use MLOps based tools like MLflow for their basic practices. Then after they can go for the Kubeflow. Then after they can go for the Comet ML. There are a lot of tools in the market. Right. Nowadays there are data ops there, DVCs there. Right. DVC is very popular too. So data versioning and model versioning is in the demand of the industry. And the last one is the explainable AI based tool where we have to check the drip, where we have to check the model variance, and we also have to check the how the model bias and what the type of suggestion they are telling. Because ultimately machine learning is a black box. How you just open that black box and how you can explain the client, because client is non-technical user. How you are explaining your machine learning model to them. So this kind of end-to-end solution you have to work on. Data scientist is only focusing on they have a data, they train the model, they get the accuracy, that's it. Still, there are a lot of data scientists who are focusing on these area only. Always look out the new solutions, but yes, never forget that if your old algorithm is working good, you don't have to go for. And one more thing, like if you are able to solve any problem with the normal programming, you don't go with the machine learning. You do not need to go for machine learning because obviously it's not a if your problem is a simple and you are able to solve that with the normal programming concept, right? Normal programming practices. Why should we have to go for machine learning, right? So these kind of mistakes, like there are a lot of people who is doing in the market. Even companies are doing that. If there is a simple processes we can handle with the normal programming, we are still trying to apply the machine learning. Machine learning is a very costly a technology, but yeah, it's open source, that's why its cost is reducing, but still scalability, infrastructure, technology, all are very costly to set up the machine learning.
Understood, understood. So like I remember when I started also, like when I was training a model, I used to actually save the model. For example, Elmo model 1, Elmo model
Hmm.
2, Elmo model
Ilmo,
3.
yes.
Then over period of time, what I understood, okay, like this is not actually working. Then
Hmm.
when the model revision concept came, then we have the version number 1, 2, 3, 4, and at any
Yes,
point of time we can download that artifacts. So I found it very helpful actually, because at that same time there was a confusion. For example, okay, Elmo model 5 was trained on which data set 1, or whether
yes,
it's data set 2.
yes,
So all these cloud solution, I think, gives us that what to say, operational flexibility in it to tag the data set also. Like, okay, for this
yes,
model we trained it with this data set, and this was the test results basically. So I find it very important whenever like we are building a production grade solution to kind of follow this best practices. I would say like this should be the practice. Like it's because if we are not following that, then like it is very much mess. Because we, after some point of time, when we are asked, okay, what is the data which has been trained for this model, we don't know, because in our folder there will be a lot of data sets, and with the same name, different names, we might forget. So yeah, like I could see the importance actually for these kind of aspects.
yes. And MLOps is a must-have practices nowadays. If you are a data scientist and if you are not giving the importance of MLOps, so you are lacking in your skills. Because let's say you want to train a multiple models, but you do not want to track that. Because what happen ultimately, the goal of any model training and any good performing model is to reproduce the result. You have to do the versioning, you have to compare the different models, you have to check that which model is performing good, you compare their parameters, you compare their performance matrices, and basis on that you can see the big picture is like what happening behind each and every model and which model is performing good on which conditions. Basis on that, let's say your data is very due to time to time, but it also contain the missing values. On that conditions, let's say tree-based algorithms are good, kernel-based methods are not good, right? From that context, like tree-based method handle very very easily compared to other like other models, right? So that's why you always have to focus on the a comparison of the performance and see the big picture, like what happening behind each and every algorithm. Because there the expertise is come into the picture. Because nowadays training the model and all the things are available in the available on internet. There is a no need of any programmer, yeah, no need any even the programmer as well, right? Like a computer programmer. Because everyone can do this by seeing that. Scikit-learn website providing this kind of tutorials to everyone, and there are a lot of people who are just giving the practical things on the market. But how you can apply, how you can solve any business problems, how is that scalable, is that justifiable, or like how much it's useful, how it's creating the impact for any objective. That is the main goal of, because there are a lot of things in the market. Are so we have to always ask: Are these useful? Are these help me to design my products? Because what happened ultimately here, the Amni technology goal is to provide the quality products to consumer. Okay, so business is the ultimate goal. So that's why this kind of the things we have to keep in mind always as a data scientist.
True, true. Yeah. So like when we are actually progressing towards a scalable AI solution, like which all frameworks do you recommend actually to your team and to your what to say?
Yeah,
Yeah.
so yeah, basically we are always prefer the open source technology only, right? So let's say your company have your own framework, but where the world is going, where the research is going, because research is always define the trend. So here you can see that nowadays PyTorch is very popular for deep learning based practices, right? In research, even in the product development as well, because of scalability and but yeah, TensorFlow is not behind that. TensorFlow has designed their own JAX packages. Then they have designed own their like a Fair, or I don't know exactly the name, Flare, which is a tensor based deep learning library for the next world. So yeah, these all the companies are constantly working behind the tech. So I always prefer the wide community support kind of, so Hugging Face is also there nowadays, which is also very popular for for even the deep learning based models like Transformer, NLP. Even it's good for the text to image, text to music, image to music. So that is known as a diffusion model. So it is providing a wide variety of support for the deep learning models. So most of the time they have a deep learning based technology, but a pre-trained models they have that. But yeah, even they have the kind of support on the enterprise level where you can just customize your model and all the things, right? So we always have to go on the direction where wide community support is available. So TensorFlow and PyTorch is the ultimate approach for the deep learning, and the scikit-learn and all are for machine learning. But yes, like for in context of ML also, I always recommend to go for open source technology. Let's say DVC and ML Flow designed by the Databricks, and DVC is itself I don't know the organization, but yeah, DVC is also the very good open source technology we can integrate with our ML pipeline.
Right, right. So one thing which I understood is like so there are solutions like which we are developing which will have a lot of frameworks. So for example, one model was trained on TensorFlow, another model was trained on PyTorch. So what happens is like if you are not deploying it into a cloud or consuming it as an inference endpoint, then the problem is like we end up importing all these libraries into our environment,
Yes,
and the Docker file becomes so big, and it
yes,
is very hard to consume in the runtime, and there is a lot of what to say, some buffer time actually automatically get creates, and like so I've seen this kind of problem where like we are finally it gets difficult to optimize towards the end because at the starting we have no license in actually developing. So I have seen this problem actually.
So in this type of condition, we have to focus on the three things. First of all, let's say you are using the TensorFlow and PyTorch both to develop the different model. So you have to ultimately your end goal is to design the file in the common format. So let's say there is a one common format is there Open Neural Network Extend ONNX.
ONN,
Right. So that is the ultimate solution. But let's say in the second point, in the context of you want to optimize your model. So for that, we have some optimization concept in the deep learning that is known as model pruning, model quantization. So you can just prune your unwanted weights and you can decrease your model size. So it will reduce around the 10 times of your model, let's say 800 MB to 80 MB. So there are availability of that kind of concept, and one model is like a knowledge distillation. Distilbert and all models are very famous for that. So that kind of approaches we have to just looking out. So if you are looking out this kind of approach, then you are able to do it to compress your models. That is the future direction, like how much you are optimize your model performance. If your model size is big, obviously latency time or giving the response of input is very high. How you can just reduce that? So that is always the challenge in a real world. So that is the main thing that we also have to deal with on day-to-day life. So these are the some solutions which I have discussed with you.
Right, right. So also, like, do you think the always it is needed for a GPU based compute every single time, or like are these models like if you optimize it in a great extent? Because recently I've seen Hugging Face actually optimizing the models to great depth using the Onyx runtime compute actually, and they do all these quantization and everything, and they actually reduce it like 5x, 6x times actually small, and then they are easily able to actually run it using a CPU. And if we deploy it just in a CPU compute without running any other thing, then it's actually good. Like it's not a that's what I've seen. Like, do you support that particular thing? Like this GPU?
Yeah,
Yeah.
future of yeah, what you are talking about, yeah, that is the innovation, but still, this is not a future. So
Mhm.
that's why TensorFlow is working behind the jacks and this kind of the tag, right? So the TensorFlow is working behind this, and what the TensorFlow is telling is that they are working behind the jacks, which is doing the faster computation compared to other.
Mhm.
Okay.
Right.
So, and other technology, what I'm talking about is the tensor computing. So tensor to tensor is there. There are some packages. Because what happened ultimately, whatever the data format is, then let's say three formats. So you have to deal with the tensor based computations. So for that we need require this kind of hardware. Okay,
Right.
but let's say we are using a machine level languages because Python is not a machine level language. So if you are using a C++ kind of programming, which is deal with directly the hardware. Right, so that kind of languages are very faster than Python. So they require less computation. Even if you do the more faster, then you can use a Linux-based system, which is provide more faster performance compared to the Windows and other computing machines, right?
Right. Right.
So that's why most of the instances are Linux-based, which is providing the good performance.
Right. I think all the VMs which cloud providers actually are providing
Linux-based, yes.
Linux based. Yeah. And do you think the parallel processing actually helps in this kind of regard? Because what I did one time was like we had this issue of this latency. So after optimization, we did like so we returned we what to say we converted the entire framework to Torch, and the vector by that means the tensor by tensor computation we had
Yes.
to actually do it because we had to remove some unwanted stuff from the framework because that was like we don't need that computation, so we
Hmm.
had to actually remove that. And then after that we what we did is like we just do it like in the threading concept actually, so we just parallelized it. So so surprisingly like it didn't crash, but like after some point of time when the load started increasing it started crashing.
Yes.
So
Yes. Yeah, this kind of happening. So, but parallel computing is not for the long run solutions. But
mhm,
yeah, in the context for the normal, so internally, let's say I have a data set and when I can do it. because like a GPT-3 kind of the model is also working behind that, and they are using the model parallelism and data parallelism concept. This is known as a there is also one book on the packet, which is a very good book. You can read. I will share the link which so that is a very famous concept, model parallelism and data parallelism. So if you can use that, so PyTorch is obviously supporting that. Even distributed computing is also supporting in the model training, right? So this kind of the concept is available and even you can apply, but it is also in the context to understand the complexity, and you will sometime lacking the performance as well. This kind of the performance variations will be found in that context. But yeah, that is not that much vary because obviously you have a large scale data set. So that's why in the one programming language that is very famous, Julia is coming into the picture. But yeah, still Julia is in the development phase. There are a lot of things are already developed, but yeah, still it is in development phase, and after some year maybe Julia will come into the market to just deal with this all. But yeah, Python will not never goes out of fashion. Yeah, it will also parallelly count after our Python Julia will be coming to the market for that on next world industry.
Right, right. So, which is your favorite cloud source provider? And like,
AWS as always.
okay, okay, okay. So,
Even Azure is there. Azure
yeah.
has their own capabilities and all. But yeah, AWS is my
So, is it mainly because of the cost factor, or like, do you have any other criteria?
the level of scalability they have, the level of infrastructure they are providing, and a lot of things. So yeah, on that context and like the faster they are providing, and that's why they are the leader in cloud infrastructure. Even they
Agree.
have a lot of good services like saving a person you cannot do at instance. Then you can directly use a one storage, like what we call it a data storage engine or whatever, like simple storage engine. So with the help of one storage, you can connect a lot of. Even you can connect your SQL thing, you can connect your document DB. With the one storage, at one storage you are accessing everything. Like the architecture design is make it more like easy to use and easy to understand. But yeah, their certification exams are very complicated.
Right, right. So, with the rise in mega models, actually, like the infrastructure demand has been like really different nowadays because like
Hmm.
these all models are very much resource hungry, and I simply can't believe how GPT-3 can be actually used if we need so many models in the
So
runtime actually.
if you want to learn about how GPT-3 was trained and how they have scaled these big hardware for training this kind of model, so that was also mentioned on that book, that
Right,
packet book. So I will share with you. That
sure.
that book is very awesome. I will share that.
Right, right. So, so how it's actually impacting the infrastructure? So, let's say when it comes to like we need to build a production grade solution for including which includes all these models basically, and not just one model. Maybe in a product like we'll be having like a series of model, like 3 or 4 models should be actually required, and all these things are pretty hard. So, like, what is the infrastructure demand in that case, and like how it's impacting the overall cost and stuff?
So like I will recommend always go through the machine learning operations where you have the synchronization that. So because what happened in the machine learning operations, there is one model known as the model registry. So you can just, let's say you have trained a 3 to 4 model. Previously your model is giving the 70 or 80% accuracy, but which is performing you in real time. So let's say you have trained more 3 models as well. So you can put on the versioning, and you can register that model for the future purpose. So let's say just some model you can put on the staging area where the tester is constantly testing the performance of that model, and if in the condition where it is not performing good or required more data to identify the new conditions. So that way you can just retrain your that model as well, and if once that find that the data scientist find it will performing good, then you can just change the status from the staging area to the production area. So that kind of also facility in MLOps. So that's why I always am now recommending every data scientist to use MLOps services.
Right, right. So, so all these mega models or like these kind of large models, like they face a lot of issues with bias and ethics actually. So, like in this regard, like, do you recommend? Because recently this Stable Diffusion came and like it was showing totally sexual bias towards women regarding
Yes.
the way it is actually showing the predictions and stuff. So, like, do you recommend like using, because it's a risk, right? Potentially, it's a risk. So what are the steps which we can actually take
As an
on this?
ethical AI, as an ethical data scientist, or I say like as a, like in a hacker, they have ethical hacker and some black hat hackers, right? So there are some good practices, there are some bad practices. But yeah, this is a concept of the research. Diffusion models are the research concepts right now. So there is no concept used to for the real world industry, right?
Mm.
So in the in the context that we are not able to, we don't have to design that, and we don't have to practice for the real world situations, because obviously when you find the buyers and it's the create any ethical issues in the for the society, obviously that things are not acceptable by society as well, obviously, and anything that affect the society will not be considered as ethical practices, right? So yeah, it's good for the just doing practices for the educational purpose, but I don't think so it will very popular industry. So like there is a one very famous model by Nvidia, right? That is a game base where you have to just type your text and it will design for you. So that is really good. So that is helping you to design background image or whatever the things. But yeah, this is the generative AI, which is a new era of artificial intelligence, and things is coming. But yeah, today's innovation become a necessity of tomorrow, right? Because let's say there are a lot of new things already in use, and if you want to generate the new things without going somewhere or without going to traveling or whatever, without photography, then generative AI is only help you out. On that context, it will help you out the graphic designer and a lot of people in the market who want to just generate the new ideas, new concept, new art, new digital things, even in like for the art, for the blockchain based industry, like people is selling their digital arts on the blockchain, right? On over the metaverse and all. So yeah, obviously AI is a backbone technology on that. So yeah, we can say that obviously when Meta was developed, generative AI becomes a very crucial part of that. But yeah, as
Right,
ethical, like in the very less industry are using these kind of advanced concepts. Because obviously you have, as I told you, if you can solve the problem with the normal logic, why should you have to go for the advanced? That is
correct,
always
correct,
applicable. Logic is a simple, Einstein told.
correct. So, so this is my final question actually. So, like, where do you think all this research is heading to? Because like a lot of big shots are actually investing a lot in this area. So, what do you see, and like, where is this research heading to in this data science space?
So they are investing behind the research technology. They are not investing behind the product technology. So obviously, let's say we want a new era of any technology. Obviously, research is always the wing which give us the wings to find the area of data science. So let's say we are here right now. We know a lot of technology about artificial intelligence, but somewhere, sometime it was a new idea, right? And they have started to develop that and they have applied in the different domains, and then after it evolved, and that's why this data science domain evolved. So few day back I wrote one post on that, is like there are a lot of machine learning algorithms, so heroes of the machine learning who has designed different algorithms for that. I will share that post with you as well, like so that way any technology is growing. So obviously starting from 2019 for NLP, but obviously it's need a more attention, and there are a lot of things, right, which is a need to be considered, because obviously let's say your client is come to you and you can't recommend that GPT-3 is there, you can directly use it. Obviously he can't scale, and obviously he can't afford, he want a customized solution. So for that you can even use your base model with, right? If your base model fulfill your requirement, you don't need to go for the GPT-3 and all. Because obviously GPT-3 size is very big. That's why they are providing the API services. They already scaled the model. They don't even need a data scientist, right? So obviously the GPT-3 is industry demand, but yeah, there are still lot of issues on the ethical side of that models, right? Because open source technology is not considered as authenticated technology for any private businesses. They want their own level of customization. Okay, so on that context, I can always recommend try to technology is always good, and every technology is help the society to grow on the particular area. Okay, but that doesn't mean like we always have to the most latest technology. You can go with the most latest algorithms if you are able to design and if you are able to understand, and if that is fulfill the client requirement. Let's say some algorithm giving the good performance on that context, so we can go with that. That is not an issue. But yeah, even we have to see the different area as well. Is like, are you able to scale, are you able to retrain, are you able to just make it retrain after some time, or are these model provide the are these model is able to handle all the real world conditions or not, are these model biased or not. And so there are a lot of kind of the question as you have to go with once your model and your data. So there is a AI canvas which is there, like you can go on the mlops.org. That canvas is even guide you on the bias side, on the drift side, and lot of things.
Great, great. So that covers all my questions for today, Ashish, and
Thank
thank
you.
you so much for explaining all these concepts. And it's pretty important to actually follow all these stuffs in production. Actually, I really appreciate you sharing your experience and working in this particular domain. So
Yeah,
thank you so much, Ashish.
thank you, Deepak.